whenever you solve the numerical, mentioning its respective unit carries marks. So A is equal to 0.3 meter per second square. Now, what is the value of acceleration? It is 5 by 3 into 10 to the power minus 3 unit is meter per second square. So this is the value of acceleration. To calculate impulse and average force, I want to know what is acceleration of the ball, which is not mentioned in the question. Hello everyone. I am Nishpananjama, Faculty of Physics in Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. Today, welcome back to Session 2 on Chapter 5, Laws of Motion. So, what did we study in the previous session? Session 1 of Laws of Motion. We studied Newton's 3 laws of motion. We shall have a quick recap of the 3 laws of motion. What did Newton's first law state? It states that a body tends to be in rest or in uniform motion until and unless it is compelled to change its state when external forces applied on it. It is called Newton's first law. We saw a few examples which explains Newton's first law of motion. And in the second law, what does Newton's second law state? The rate of change of momentum dp by dt is directly proportional to force F, and it acts in the direction of force, and we derived the expression for force F is equal to ma. Then we studied what is impulse of a force. It is the force acting on an object or a body for a very short period of time. A cricketer hitting 6 or a bullet striking a glass is an example for impulse, represented by J, and its unit is ns. And next, we studied Newton's third law of motion. It's very important. Every action has an equal and opposite reaction. If you have an action, you will have in return reaction. So bouncing of a ball is an example for Newton's third law. So with these 3 laws, in today's session, we'll solve few numericals that comes in the 5th chapter, Laws of Motion. So along with me, you try to solve the numerical. So here is our first numerical of chapter 5. Let us read the question. A force of 0.12 Newton. Let us write the given things first. Whenever you solve the numericals, first read the question and write what is given in the numerical question. A force of 0.1 Newton. N represents, it is talking about force. F is given, it is 0.12 Newton. Acts for a 3 seconds. T, time T is given. T is equal to 3 seconds. On a body of mass 0.4 kg, that means mass is given 0.4 kg. At rest, find the velocity gained by the body. Listen, a force of 0.12 Newton acts for 3 seconds on a body of mass 0.4 kg at rest. So find the velocity gained by the body. Then which is your initial velocity, which is your final velocity here? He's telling it is at rest. That means your initial velocity is 0. You need to find out what is the final velocity when it is at rest. Its mass is 0.5 kg. The force is exerted is 0.12 Newton. So with 3 seconds, it moves, it accelerates. That means you have to find out what is the velocity gained by the body after 3 seconds. Initially it's at rest. After 3 seconds, at that particular time, what is the velocity of the body? That means you should calculate the final velocity represented by capital, that represented by V. So U, initial it's at rest, so initial velocity is 0. So whenever a question is asked, be clearly you have to mention the U and the V, the difference. Read the question, analyze, and then come to the conclusion for the values of U and V. Now to calculate V, first I know F is equal to MA. F is equal to MA formula. Force is equal to mass into acceleration. I know what is force, 0.12 Newton. I know what is mass. Using these two, I can get what is acceleration of the body, right? So from Newton's second law of motion, I know F is equal to ma. Substitute the value. F is equal to ma. What is F here? 0.12 Newton is equal to what is mass? 0.4 kg into A. So I want to calculate what is A. So what I'll do, it is 0.12 divided by 0.4. 0.4. Now I'll get what is the value of acceleration. On simplifying, the value of acceleration is 0.3. It is meter per second square, unit for acceleration. Whenever you solve the numerical, mentioning its respective unit carries marks. So A is equal to 0.3 meter per second square. So once you have the value of acceleration, I will consider the equation of motion. The first equation of motion, notice that V is equal to U plus AT to calculate what is the velocity, speed gained by the body. What is the velocity gained by the body? I want to know what is V. To find the value of V, I will consider the first equation of motion. Why I consider first equation of motion? Because T is given. The numerical is with respect to time. So when time is given and they have not given you distance S, so it is just time is given. I know acceleration, I know what is U, and I have to calculate what is V. So I will consider the first equation of motion. So V is equal to, you know what is the initial velocity? It is at rest. That means initial velocity is 0 plus A I have calculated already. A is equal to 0.3 into what is the time taken by the body? 3 seconds. So 3 seconds. So this will give me the value. What is 0.3 into 3? That will give you 0.9. 0.9. What is the unit for velocity? It is meter per second. Meter per second. This is the velocity. This is the velocity gained by the body for a time 3 seconds. So I got what is acceleration. With the help of acceleration from Newton's second law, using first equation of motion, I got what is the value of velocity is 0.9. Velocity unit is meter per second. For acceleration, meter per second square. So this is how you solve numerical. Next, let us again look at one more numerical. So what does it state? A ship of mass. So along I am reading the question as well as I am writing the given things in the question. When I write given things, it will help me to connect the relevant formula to the question that is being asked. So a ship of mass. What is the mass? That means M. Mass is M. It is given, it is 3 into 10 to the power 7 kg. Mass is measured in kg. Initially at rest. He is telling it is initially at rest. Is pulled by a force. It is pulled by a force. That means it is force is 5 into 10 to the power 4 Newton. Through a distance of 3 meter. Now S is given. S through a distance of 3 meter. It is pulled for a distance of 3 meter. The displacement of the ship is 3 meter. Assuming that the resistance due to water is negligible. Assuming that the resistance due to the water is negligible. Find the speed of the ship. He is asking you to find the velocity of the ship. So initial velocity is 0. So what is the final velocity of the ship? How will I tell initial velocity is 0? Because a ship of mass 3 into 10 to the power 7 kg initially at rest. It is not applied with some initial velocity. So U is 0. It is at rest. Is pulled by a force 5 into 10 to the power 4 Newton through a distance of 3 meter. Assuming that the resistance due to water is negligible, find the speed of the ship. Speed of the ship is nothing but is asking you to find the final velocity of the ship after applying 5 Newton of force and pulling for 3 meter distance. Now, how will I to calculate V? What should I need? For applying equation of motions, I need to know what is the value of acceleration. So I know from Newton's second law, force is mass into acceleration. So force is given 5 into 10 to the power 4 Newton is equal to mass is given 3 into 10 to the power 7 into acceleration I have to find out. Bring the 3 to the denominator of the LHS. So it will be 5 into 10 to the power 4 Newton divided by 3 into 10 to the power 7 kg is equal to A. Now, what is the value of acceleration? It is 5 by 3 into 10 to the power minus 3 unit is meter per second square. So, this is the value of acceleration. 5 by 3 into 10 to the power 7 minus 4 is 10 to the power minus 3 meter per second square. Now, I got what is the value of acceleration. Which equation of motion I will use to find the speed, velocity of the ship. Listen carefully, look at the given things. Mass, force is given, S, the distance is given, time is not given. So, initial velocity is 0 and I have acceleration value. So, I'll use third equation of motion. Which is that third equation? V square is equal to U square plus 2AS. 2AS to find out the velocity V. To find out the velocity V. Now, I want to know what is V square. I know what is U. It is 0 square. 0 plus 2 into what is A now? It is 5 by 3 into 10 to the power minus 3 into S is given. It is 3 meter. It is 3 meter. On simplification, what is the value you will get? You will get 10 to the power minus 2. We'll get 10 to the power minus 2. On shifting point, it is nothing but 0.01. 0.01. It is V square. So, what will be your velocity? What will be your velocity V then? Velocity will be 0.1 meter per second. 0.1 meter per second. So, you have 10 to the power minus 2. 10 to the power minus 2 is shifting the 2 points. You have minus 2, 0.01. So, V square is there. So, V is equal to 0.1 meter per second. So, velocity of the ship V is equal to 0.1 meter per second. Force is given. From force and mass, I'll get what is the acceleration of the ship. Once I get acceleration, I will use the third equation of motion because I have to use the equation which is independent of time. Time is not given but distance is given. So, I'll use the third equation of motion. On simplifying, you'll get the velocity of the ship V is equal to 0.1 meter per second. Similarly, we have third numerical. A cricket ball moving horizontally with velocity 12 meter per second. So, a cricket ball is moving horizontally with a velocity. So, your initial velocity is given. It is moving with the initial velocity U of 12 meter per second. Is brought to rest by the player in 1 second. 0.1 second. It is brought to rest by the player in 0.1 second. If the cricket ball weighs, that means mass is given 0.15 kg. By looking at the unit, you can guess what is given. So, it is in kg. That means mass is given 0.15 kg. Calculate impulse. In the previous session, we have learned what is impulse and what is the formula to calculate impulse. Please go back to the previous session. So, calculate impulse and average force F applied. Force as well as impulse I have to find out. Now, I have U is equal to T is equal to mass is equal to. The values are given. So, I need to find what is acceleration now. U is given, the initial velocity, at time 0.1 second, cricket ball is brought to rest. That means your final velocity will be 0. It is moving with initial velocity 12 and it is brought to rest. That means It is brought to rest in 0.1 second. So your final velocity will be 0. Mass is given. Calculate impulse and average force. To calculate impulse and average force, I want to know what is acceleration of the ball, which is not mentioned in the question. So what I will do, I will use the first equation of motion because it is with respect to time. The distance s is not mentioned. So it is v is equal to u plus at. Substitute. I know when it is brought at rest, the final velocity is 0. 0 is equal to, what is the initial velocity? It is 12. 12 plus, I don't know what is the value of a. I need to find out. So a is as it is into time. I know it is 0.1 second. It is 0.1 second. So it will be 0 is equal to 12 plus a 0.1. A 0.1. So on shifting the terms, I want to know what is a. So minus 12 by 0.1 is equal to a. A will be minus 120. Substitute, find out using the calculator. It will be minus 120. Unit is meter per second. This is the value of acceleration. This is the value of acceleration using equation 1. First equation of motion. On simplification, I got the value of acceleration. When 12 is brought to, it is equated to 0. When 12 is brought to LHS, it will be negative. Minus 12 divided by 0.1. It is multiplied. So when it brings down, it will be division in the denominator. 0.1 is equal to a. On simplification, you get minus 120 meter per second. Minus is nothing but the direction. Acceleration is in one direction. Acceleration is in one direction. Acceleration of the ball is in one direction. When the object is moving forward, you will hit it to slow down. When the object is moving in one direction, you will hit it to slow down. That means you are applying force. So the force will be in opposite direction, right? So the batsman is applying force. So it is positive, right? So the positive force will be in opposite direction. Acceleration is in one direction. So you'll hit the ball to slow down, which is moving forward. So you're applying some force. The force will be opposite, right? So the batsman is applying some force. That is why force will be positive. When you calculate force from second law of motion, F is equal to ma. F value I have to find out. F is equal to m, I know, mass 0.15 into acceleration, I know. So the force that applied to slow down will be positive. I'll take acceleration is 120 meter per second. If you multiply your force F will be 18 Newton. 18 Newton. Now I know what is force. Unit for force is Newton. I want to calculate what is impulse. What is the formula for impulse? Impulse is given by F into T. What is the force? 18 into what is time? 0.1 second. So your impulse will be 1.8. Unit for impulse is N. Yes. This is your impulse. So you got what is force, 18 Newton. Using force and you know what is time, you can calculate impulse, that is 1.8 Newton second. So this is how you solve the third numerical. Next you have the fourth numerical. Let us read the question and write the given things in the question. A bullet of mass 0.03 kg enters a block of wood with a velocity of, that means your initial velocity with which the bullet is moving to enter a block of wood is given. It is 600 meter per second is the unit for velocity. So you'll get to know they're talking about velocity, and penetrates to the depth. So the depth, that means distance is given. It is moving a depth, distance 0.2 meter. Look at the unit. It is talking about distance. Calculate the average force F of the wood to the penetration of the bullet. So M is given, initial velocity is given, distance is given, final velocity will be 0. So what is given? Mass is given, initial velocity with which it is moving. It is given, I know the depth. depth, that is distance, is 0.2 meter, and final velocity will be 0. Final velocity will be 0. It is not mentioned, but initial velocity with which the bullet move is already given. Now I will use the third law, third equation of motion. U is equal to V square is equal to U square plus 2AS. 2AS, because it is with respect to distance, yes, where time is not given in the question. So I'll use the third equation to calculate acceleration. I want to know what is acceleration, to calculate what is the force. So what I'll do, V square, that is 0, is equal to, what is U square? It is 600 square plus 2. I don't know what is A. I have to find out, into S is given. It is 0.2 meter. So it will be 600 square plus 2 into A into 0.2. So on simplification, your A will be, it is equal to 0. So bring it to LHS. So it will be negative of 600 into 600 divided by 2 into 0.4. It will be 2 into 0.2 will be 0.4. It will be 0.4. A is equal to 600 square. So when you bring this side, A is equal to minus 600 into 600 by 0.4. So what will be the value of acceleration? It will be, what will be value? On simplification, you will get it is minus 9 into 10 to the power 5 meter per second square. This is the unit for acceleration. This is your acceleration A. Once you know what is the value of acceleration, so you know this negative sign is the direction, that is specifying the direction, that acceleration is moving in one direction. If it is moving in the one direction, the force applied to slow it down will be in opposite direction, right? So the force applied will be positive. So when you calculate force, F is equal to ma using Newton's second law. M, I know what is the mass. It is 0.03 into, I know what is acceleration, but the force applied is to slow it down is positive. The force applied to slow it down is positive. So I'll take the positive value of acceleration. It will be 9 into 10 to the power 5. So what will be a force? It will be 7 and double triple. So it will be 27,000 Newton. 27,000 Newton. That is nothing but it will be 27,000 Newton. This is the force applied, average force applied. So force applied is 27,000 Newton. So how did you get? I used third equation of motion, V square is equal to U square plus 2AS, using that because the distance is given with respect to distance. So I substituted the value of U plus 2 into A. I have to find out S is given, the distance, the depth, it is 0.2. On substitution, how did I arrive at this? That is nothing but equal to, I'll get it as 600 square plus it will be 0.4A. So it is equal to 0. That will be equal to 0. So when you shift the term, I want what is A. So when you shift the term, it will go that side. So it will be negative 600 square divided by, it is multiplied A into 0.4. When it goes to the denominator, it will be division. A is equal to 0.4 is equal to A. This is how I got into this equation. So on simplification, I got what is the value of A. It is minus 9 into 10 to the power 5 meter per second square. So on simplification, they were asked to find out what is the force, average force, F. I want to know F. So M is given, A I have found out. So on simplification, I will get to know what is the average force of the wood to the penetration of the bullet. So next you have the fifth numerical. Read it clearly. Read it clearly. A cricket ball of mass. Again, write what is given first. Then connect the formula relevant to the question. So the mass is given. It is M is equal to 0.18 kg. It is 0.18 kg. It is moving with the velocity. That means it is moving with the velocity. It is at the origin. It is moving with the velocity. It is initial velocity is given. It is 10 meter per second. Unit for velocity. It is hit by a bat so that the ball is returned back. It is hit by a bat, so the ball is returned back with a velocity. That means final velocity. It will move with initial velocity. It is hit by the bat. So the ball will return back with the final velocity. It is 20 meter per second. The force of the bat acts on the ball for 0.01 second. So time is given, t is equal to 0.01 second. So find the average force. What is the force exerted by the bat on the ball? The force of the bat acts on the ball for only 0.01 second. That means time is given. I need to find out what is force. What is force? Look at the question carefully. Both the velocities are given, u and v. Both the velocities given. To calculate force, what I want? I want acceleration. But look at here, both initial and final velocity is given. Time is also given. That means how will you calculate acceleration? You can use the formula F is equal to m of v minus u by t. V minus u by t. Your final velocity is given, your initial velocity is given, time is given. By substituting that, you can get acceleration. What is acceleration? It is nothing but v minus u by t. Change in velocity. Final velocity minus initial velocity by time gives you acceleration. Substituting that, I will get what is my force applied by the bat on the ball. So if I want to calculate, see, since the ball is returning back in opposite direction, I'll hit the ball. The ball is moving in one direction. The ball is returning back in opposite direction. So we'll take the initial and final velocity with the opposite signs. If I take v as positive, if I take v is positive, since the ball returned back in opposite direction, initial and final velocity will take the opposite signs. So if v is positive, then u is taken as negative. It is minus 10 meter per second. Now you simplify in this equation, you'll get the value. Your mass is given, it is 0.18. Your final velocity is given 20 minus of minus 10 is your initial velocity divided by time taken is 0.01 second. So minus is what? It is plus. So when you simplify further, you will get force is equal to 540 Newton. Force is equal to 540 Newton. Simplify. 20 minus is plus 20 plus 10 divided by 0.01 into 0.18 will give you 540 Newton. So since the ball is hit in the one direction and the ball is returning back with this much of velocity, the ball is returning back with in opposite direction. So that means initial and final velocity taken with opposite sign. That is, if I take v is positive, because for the simplification, if I take v is positive, u will be minus 10 meter per second. Return back in opposite direction, I have the initial and final velocity of the ball is taken in opposite direction. The initial and final velocity of the ball is taken in opposite direction. On simplification, you'll get what is the value of force. That is 5 Newton of force is the average force exerted by the bat on the ball to move the velocity 20 meter per second. So this is how you solve numerical. When both velocities are given, you can directly calculate acceleration using v minus u by t. So this is the value of force. Even you can use the first equation of motion. V is given, u is given with respect to time. Time is given, but distance is not mentioned. So you can use the first equation of motion and check out whether you can get the same acceleration value. You can check the acceleration value. Using that acceleration value, multiply the mass and you can check whether you get the same value of force. Same value of force using the first equation of motion. V is equal to u plus at. That's all for today's session. We have solved the numericals based on new equations of motion and also based on F is equal to ma, that is Newton's second law of motion. Next, I'll come up with more interesting session on laws of motion, that where we'll study the conservation of momentum and equilibrium of particles in the system. Until then, take care. Have a good day. Thank you.